Basic Skills 7, number 1. So again, represent the sample space for number 1. So a spinner can land on either red or blue you spin once. So imagine if we have our spinner here. Here's our red section. Here's our blue section. So what are the possible outcomes if we spin this spinner? Where can it land? Here's our little arm. So it can land in either red or it can land in blue. And that's our sample space. Our possible outcomes there of where the spinner hand can land. Number 2. Determine whether the scenario involves independent or dependent events. So a box of chocolates contain 8 milk chocolates and 4 dark chocolates. You randomly pick a chocolate and eat it. Then you randomly pick another piece. The first piece is milk chocolate and the second piece is dark chocolate. So this is considered dependent, and here's why. Because we ate the piece. Because we ate the piece, it changes the second outcome, the second probability of our scenario here. So let's do milk chocolate as brown. And then we have dark chocolate, that'll be black. So we have 8 milk chocolate pieces. There's 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 dark chocolates. 1, 2, 3, 4. Now we're blindfolded, we're reaching out in a bag, we don't know, we don't see what we pick. So the first time we pick, you randomly pick a chocolate and then eat it. So the first time we pick, we have a total, we're picking 1 out of a total 2, 4, 6, 8, 10, 12. 12 total candies in this bag. The second time we pick it, right, we pick another piece. So we picked out, let's say we picked out this piece here. We're picking out 1 out of this time because we ate that piece. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And notice how our probability here changed. Because that changed, we are going to call this dependent events, right? Because we took that first piece, we didn't put it back, we ate it. So it's dependent. So our second pick is dependent on our first pick. Number 3. So determine if events A and B are independent. So to check for independence, we need the probability of A and B to equal the probability of A times the probability of B. So they give us all of this. Probability of A and B is 0.27. Right, and I'm looking at this here. I went ahead and put that in a calculator. 27 divided by 100 is 0.27. Is equal to the probability of A, which is 9 over 20, which gives us 0.45, times the probability of B, which is also 9 out of 20, which is going to be the same exact thing. So let's see if these two sides are equal to one another. 0.45 times 0.45 gives us 0.2025 equals 0.27. So those are not equal. These are dependent events. So this is dependent. Let's look at number 4. So for number 4, it's conditional probability because we have that given sign here. So for conditional probability, the probability of A given B should equal the probability of A and B divided by the probability of B by itself. So some of this stuff we have. Probability of A given B is 13 out of 20, which is 0.65. So I'm going to go ahead and put 0.65 here, is equal to the probability of A and B. So to find A and B, we just have to multiply those two together, right? So just like we had here, probability of A and B is equal to the probability of A times the probability of B. So I'm going to grab my calculator. 13 divided by 20. 13 divided by 20 times, so A is 13 over 20 times B, which is 13 over 20. Okay, so in my calculator, I went ahead and I put probability of A times B, so I put 13 over 20 times 13 over 20 divided by the probability of B by itself, which is 13 over 20. Okay. So simplifying this out, 13 over 20 times 13 over 20 was 0.4225 divided by 13 divided by 20 by itself is 0.65. So now one last step, just simplifying this out. We had 0.65 is equal to, and I'm going to divide this out. 0.4225 divided by 0.65 gives me 0.65. So these two are independent, right? Because these equal one another. These are independent events. Okay. Let's look at number 5. So number 5 tells us that events A and B are independent. So we know they're independent already. So find the missing probability. So this is going to require some algebra. So we have the probability of A and B is equal to the probability of A times the probability of B. Again, I just copied that from number 3. So A and B is 3 out of 20. We can take our calculators, make that into a decimal. 3 out of 20 gives us 0.15. Is equal to probability of A we don't know. We're going to put an X there. Times the probability of B, which is 1/4. 1/4 to decimal form is 0.25. So simple algebra, divide by 0.25 on both sides. Those cancel. We're left with X equals 0.15 divided by 0.25 gives us 0.6. Number 6, find the probability. So we're given situations here that we need to find the probability for. So you flip a coin twice. The first flip lands heads up. The second flip lands tails up. So imagine if we were to make our chart. So we do our first flip, we get heads, we get tails. We do our second flip, we get the possibility of a heads and a tails, and the possibility of a heads and tails. So if we're looking at our sample space, we have heads, heads, we have heads, tails, we have tails, heads, and we have tails, tails. So the first flip lands heads up, so we want our first flip to be heads up, so we're looking at these two. And the second flip lands tails up, so we want heads, then tails, and the only one that gives us that is this here. So that is a 1 out of 4 chance, or 25%. Let's look at number 7. So a bag contains 6 red marbles. So let's draw out our 6 red marbles. There's 1, there's 2, 3, 4, 5, 6. And 5 blue marbles. 1, 2, 3, 4, 5. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. The first marble is red. and the second marble is blue. So imagine these are all in a bag. We're blindfolded, we can't see what we're picking out. It's totally random. So the first pick is a red marble. So that's 1 out of a total of 2, 4, 6, 8, 10, 11 total marbles. So 1 out of 11. And we got a red. So we're not going to return that. We're going to keep that with us, right? Because it says without returning. Now, what's the chance that we get a blue the second time? So the first is red, and the second is blue. Oops, sorry, this should be a 6. There were 6 total reds in there. So now for blue, how many chances? We have 5 different ways to get blue out of a total of, this time, because we didn't return that 1 marble, out of 10. So the first is red, right, 6 out of 11 chance. The second is blue, 5 out of 10 chance. We're multiplying fractions, you multiply straight across. That's 30 divided by 110. 30 divided by 110 gives us about a 0.2727 forever, or 27.27. .27 forever percent, because that decimal ends up repeating. Number 8. Find the number of possible outcomes in the sample space. So a hot dog stand offers both small and large hot dogs. Each hot dog can be ordered plain or with ketchup. So find the number of possible outcomes in the sample space. So here's our small hot dog, here's our large hot dog. Each one of these can be plain or ketchup. Plain or ketchup. Now the total possible outcomes, just like we did with the heads and tails, we have small and plain, small and ketchup, large and plain, large and ketchup. So we have 4 possible outcomes, and they are these here. There's our list. Number 9, determine if the scenario involves mutually exclusive events. A box of chocolates contained 4 milk chocolates and 4 dark chocolates. So let's go ahead and start drawing this out. So here's my 4 milk. 1, 2, 3, 4. And we have 4 dark chocolates. Dark, 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 dark. One of the milk chocolates and one of the dark chocolates have peanuts inside. So one of these is with peanuts and with peanuts. You randomly select and eat a chocolate. It is a milk chocolate or has no peanuts inside. So let's go ahead and write that formula out. So the probability of a milk chocolate or, right, or is that U-shaped one, no peanuts. Okay. And if we go ahead and we extend that out, we look at our OR formula, probability of A or B is equal to the probability of A, in this case it's milk chocolate, plus the probability of has no peanuts inside is equal to the probability of milk chocolate and no peanuts. Okay, so we can start filling this out. We can use the fractions or we can use decimals. I think decimals are always easier to use. So let's look at this first one here. Probability of milk chocolate or no peanuts. So here's our milk chocolates. That's 1, 2, 3. And because of that no peanuts, we can't use this one here. Oh, sorry, we can use this one here. That is milk chocolate. This one has no peanuts, no peanuts, no peanuts. This is not milk chocolate, and it doesn't have any peanuts, so we can't use the DP one. So if we're looking at that there, that's 7 out of 8 that are milk chocolate or has no peanuts. So 7 out of 8, we put that in our calculator, get the decimal. We're looking at 0.875 is equal to. Now, what's the probability that we have milk chocolate? So for milk chocolate, here's a milk chocolate, here, here, here. That's 4 out of 8 total. Right? These are all dark chocolate. So 4 out of 8, that's 1/2, that's 0.5, plus, what's the probability of no peanuts? So no peanut, no peanut, no peanut, none, none, none. So we're looking at 6 out of 8, and 6 out of 8 is 3/4, which is 0.75, which equals the probability of milk chocolate. Oh, sorry, this should be subtract. Subtract the probability of milk chocolate times no peanuts, which is this times this. Right, we found those probabilities already, so 0.5 times 0.75 gives us 0.375. So now just simplifying this side here, simplifying the right-hand side there, 0.5 plus 0.75 minus 0.375. Sorry, that's 0.5 plus 0.75 minus 0.375 gives us, I'm rewriting some things here, 8.75 is equal to 0.875. So we have mutually exclusive events here. So roll with that there. And number 10. So we know that A and B are mutually exclusive. We want to find the missing probability. So if you look over there, we have a OR statement. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Right, and A and B, that just means A times B. Let's start plugging in. Right, so the probability of A or B is what we're looking for. So that's X equals the probability of A, if we change that to a decimal, 0.2, plus the probability of B, 1/4, change that to a decimal, 0.25, minus, this is going to be, if we write this out, that's 0.2 times 0.25. Let me write it this way so it's less confusing. 0.2 times 0.25. And we get that X, which is the probability of A or B. So we got 0.2 plus 0.25 minus 0.2 times 0.25, and that gives us 0.4. So off to the side, we can write the probability of A or B is equal to 0.4.